we've got one more method we need to look at, Math.random. Now, Math.random does kind of what you would think it does. It produces a random number. It's technically a pseudo-random number. So it's very difficult for a computer to generate a truly random number. So it does it based on a process, but for most purposes, a pseudo-random number is going to be close enough. So what it does, it produces a uniform double, okay, a decimal number in the range 0 to 1. Now, 0 is inclusive here, and 1 is exclusive. So it's 0 to 0.99999. And we're going to use this random number mostly for simulation purposes, okay? Simulating a random event, simulating stuff that is governed by probability. It's something that's actually pretty useful. There's even certain times where it's easier to simulate a probability with the computer rather than actually calculating the probability with true mathematics. Now, down here you'll see we're going to generate 5 random numbers. Now, it should be different each time. You have to be very careful. If you have a random value that you want to use more than once, you better make sure and save it, because the next time you call it, it's going to be different. So we've got these random numbers, but a lot of times we don't want it to be between 0 and 1. So let's say I want this number to be between 0 and 100. Well, all I'm going to do is I'm going to multiply by the size of my range. So if I want to expand my range to 0 to 100, so that range is now 100. So I'm going to multiply by 100. And the reason this works is, if you think about it, 0 is 0 times 100. And 100 is 1 times 100. So if you take this thing that can go from 0 to 1 and you multiply it by 100, the range goes from 0 to 100. Similar thing if we want to go a more specific range, like 50 to 60. So 50 to 60, the range of those values is 10. So we're going to multiply by 10. So we go from 0 to 1, from 0 to 10, to 0 to 10. And then all we have to do is shift that up higher. So we go from 0 to 10 here to 50 and 60 up here by adding 50. So we multiply by 10, and then we shift it up 50. So again, this is 0 times 10 plus 50. This is 1 times 10 plus 50. So that kind of makes sense why that works mathematically. We're just adjusting that range of values. Now, sometimes instead of generating a random double, we want to generate a random integer. Now, this is a little trickier. So let's say I want random integers between 0 and 9. Well, from what we said before, okay, 9 minus 0 is 9. So we need to multiply by 9. That doesn't work because if you remember, we get really, really close to 1, but not 1. So if I do 0 times 9, yes, that will give me 0. But if I do 0.999 times 9, that's going to get me 8.9999. Now, what that does is that leaves me 0 chance that I would get a 9. And even if it did actually include that, there would still just be this almost impossible chance for me to get a 9 when I'm trying to get these random integers. So what I do is, instead of doing times 9, I do it times 10. So when I do this, And now I'm generating numbers from 0 to 9.99999. And then when I change it to an integer, that will give me integers from 0 to 9. So same concept. If I want a more specific range of integers, I do the same thing. So my range, 6 minus 1 is 5. And then we have to add 1 for those reasons that I just mentioned. So I would multiply by 6. Okay? But instead of going from 0 to 5, we add 1, and it goes from 1 to 6. If you want to see the general rules, I've written them up there. But again, for integers, it's that range plus 1 to catch the integer. And then if you need to shift up, you add a value. So that comes in handy. Hopefully you saw 1 through 6, a random int 1 through 6. That's simulating a dice roll. And you can see where that would be useful in games or other simulations.